Thanks, Carly. So I'm also based here at Lancaster. I'm one of Ezra's other supervisors. What I'm going to talk to you today really sort of incidental data really, because I do one of the UK bugfly monitoring scheme transects on water crag, and it takes quite a long time. It's like more than 4 kilometres long, and then lots of it there's not that many bugflies. So I thought I'll spend a lot of time here. So I thought, I know I'm going to try and quantify insect flower interactions as I go, increase the value of all this time I'm spending. So what I'm going to present today is sort of like incidental data that's been collected alongside my butterfly monitoring scheme data. So here we go. Those of you who don't know Warton Crag, just on the southern end of the Ironside and Silverdale National Landscape. That's a picture from the south about 4 or 5 years ago, and what you notice is it's a limestone hill. There's an old quarry, a series of limestone crags, but the predominant impression you get is sort of quite wooded areas with some more open areas that are managed to keep it quite open. I live in Warton, so I'm on the Warton Village Facebook group, and there's some people that are really into history there, and they gratuitously keep chucking pictures on of Warton Crag in ancient times, not so ancient times, but so I just wanted to show as a way of contrast. This is a picture I think from sometime in the 1920s of what Warton Crag looked like then. See, very sparsely, very few trees, very open landscape, and at that point up until the 1940s it was sheep grazed, quite extensively sheep grazed. It's another picture I think supposed to be from the 40s. I thought put this up because anyone who knows Warton Crag will know that those sort of terraces between the crags now are largely bracken beds, really quite densely bracken beds. You can see they're sort of very different than what you might see nowadays. So clearly the site is very different than it was 100 years ago, 70 years ago, or thereabouts. It's one picture of what it looks like, a gratuitous, nice view of what it looks like. It is from the midpoint of my butterfly transect. So what you see now is, with a closer look, you do see areas of pavement or sort of sparse limestone outcrops with calcareous grassland clearly in the gaps in between, but also quite large areas of bracken beds on the deeper soils principally, and also quite a lot of wooded areas. So that's really, we've got the transect goes through a mosaic of all those sort of habitats. Site is managed. It's managed to try and maintain the calcareous grassland. It's also managed for some of the butterfly species that like more open habitats. So we have some sections that periodically have all the scrub removed, such as that. And over here, last couple of years, it's been grazed quite extensively, but grazed sort of year round. And the cattle now are relatively free to roam across the whole site. And so largely there is all the open areas that still persist really are either on very sort of rocky pavement type habitats or where there's been quite intense management. Don't want to keep them open principally for butterflies. And the other factor, I just put this in just to remind me clearly in the last couple of years, a huge amount of ash dieback as well. So this winter in particular, a hell of a lot of tree fall, presumably some of those dead ash trees coming down. So it is becoming more open than it was a couple of years ago. So my butterfly transect is in the Wildlife Trust managed portion of Warton Crag, the northern section. So it's away from those south-facing slopes, and it is 15, but I'm going to say 13 sections, starting off the woodland and going through all these more open areas across the site. I'm just presenting that because the data I'm going to show is sort of working on a section level across the site. So I do this as a butterfly monitoring transect. It's about 4.2 kilometres, and say 13 sections. One of the problems is their varying length, which gives some statistical problems, but we can deal with that. So what I did actually for the pollinators is just record 50 centimetres either side of the disturbed area of the path. So smaller area. So I'm monitoring all sort of insects on flowers as well as I can, because I'm doing the butterfly contact. I can't catch everything and I can't spend hours trying to identify everything, but I did the best I could to identify what I'm seeing. And then last year, so the first time last year, I did an independent walk to quantify floral abundance every couple of weeks through the season as well. So account about how many flowers, how many floral units were available across the whole transect length. And also when I thought, oh, I'm getting quite a lot of data here, this looks quite good. Last year, I also went back and then approximately every sort of 50 meters through the whole transect, I did a habitat assessment, just really crude, sort of estimating at each of those points, estimating the percentage cover of sort of woodland, short scrub below 2 meters, scrub 2 to 5 meters, or open pavement stroke grassland sort of habitat. So points for every 50 meters across the whole transect, an assessment of habitat composition within a 20 meter sort of diameter. So those are the data I'll tell you about a little bit later. So jumping straight ahead to an overview of the whole data, what plants are visiting most? And that's basically looking at the whole last season, April through to September, walking pretty much every week if weather allowed, and that's just quantifying all the visits to different species. So what you see, what comes out on top, which surprised me actually, because I didn't feel like that at the time. Of those almost 3,000 visits recorded, we've got hogweed, we've got knapweed next, bramble, hawkbit, tom and till, and then a whole bunch of those sort of yellow composite species, which insects tend to like. I'm not a botanist, you might have got that. Lots of species that are commonly visited, and then lots of species that are very rarely visited actually, and hogweed coming out on top across the whole season. Now clearly there's a temporal dynamic in that. It's a very messy slide, so I'll sort of talk you through it, but what we've got here is just breaking that down into months, and I've just presented all the species that within at least 1 month made up 10% or more of visits. And it's probably, if I asked you what would happen, you'd probably say this. And we all know early on we've got celandine and dandelion. Later, and then once the bramble starts flowering, that sort of takes over. Dandelion carries on, and then you get an emergence in the mid-season. You get the hogweeds coming out, and hogweed and bramble are dominating until the knapweed flowers. Knapweed and hogweed, and then at the end of the season, well, they persist really through the end of the season. So it's pretty often hear people say, "Oh yeah," stating that knapweed is really important for pollinators later in the season because there's not much out there, and the data sort of do support that view. In terms of the insects, what I've got here is a bunch of sort of quantitative interaction weights where we've got I've just simplified it to the insect orders on the top. So this one is first the true flies. This is including hoverflies as well, so it's the whole Diptera. So the way this works is the width of that bar is proportional to the relative abundance of that group. So the flies were the most abundant visitors, followed by the bees, wasps, etc., beetles, butterflies. And similarly at this end, the width of the bar is proportional to how common that flowering species was visited. And so what you can see, what it allows you to do is say, okay, quite a big chunk of all those fly visits are to hogweed. And from a hogweed perspective, almost all the visits that it gets are from flies rather than the other groups. Okay, so for the flies, lots to hogweed, then quite a substantial proportion to knapweed, bramble, and then all those yellow flowers that we like. For me as a non-botanist, having scratched my head quite a lot in the early part of the season. When we look at bees and wasps, etc., it's sort of a very different pattern. Hogweed is almost not visited at all. But knapweed, bramble, dandelion, also quite substantial portions of their visits. We look at beetles, much fewer data here, but pretty equally distributed across most of those key flowering species. Quite a lot of beetles on hogweed. All of those pretty much are red soldier beetle, which apparently is also named as, well, does anyone know what its other common name is? Hogweed bonking beetle, apparently. And that is true. Most of them, I've only got even counts of that species on hogweed for that reason. Butterflies and moths, again, don't really see them so much on hogweed. Knapweed, bramble in the main, and then a splattering across most of those different sort of yellow Asteraceae. So that's sort of an overview of what flowers are there and what flowers are being visited, really, and by what. And you see the different insect groups do vary a little bit in what they tend to visit, which is sort of what we would expect from the basic ecology of it. Of course, those different flowering species occur in very different abundances. So they differ in their availability to insects as well. So what I've done here is have the proportion of insect visits in the whole data set and plot it against the proportion of floral units. So this is sort of controlling for their availability. So in effect, points that go above the 1-to-1 line are species that are visited more than you would expect based on how abundant they are. And below the line are species that the opposite are visited less than you would expect them to be based on their abundance. And they go no real surprises, but most of those species we've mentioned already are very much up in the top portion. So they are, although there are some of these probably isn't that common actually, but some of these are very common. They're visited more than you would expect, even accounting for their abundance. As a contrast to things like tomantil and bluebells, really not favoured at all. Part because of them themselves, but in part because of where they're growing, because then some of those species aren't growing in open areas where you tend to find lots of pollinators. So that's the really common stuff. That little box there contains loads of species. So we can just to focus in on that box, it pulls out some of those other species we've mentioned. So most of those sort of yellow Asteraceae are very much favoured. Buttercups aren't. Buttercup pollen is toxic to a lot of insects, so they tend to not be visited so much. And then most of these species are sort of more woodland species of more darker habitats. So we don't know whether it's the flowers are not very visited or whether it's just that they're in darker environments. I've got to speed up. So quickly, so the interesting question from my perspective is, can we look at this transect and ask what impact has that change in habitat have? So will that scrub encroachment, the change of much of that habitat to woodland from open areas, what does it have, what impact does it have on those pollinator communities? So what I've done here is with those habitat data, I basically came up with an index that just says for a particular section of the transect, how wooded it is it? So this index is 0 if it's totally open, and it's 1 if it's totally mature trees, and the other fall in between. And we can then say, using each of the sections of transect as a data point, we can ask questions about what is controlling how many visits we get. So this is just looking at basically how many insect visits per meter squared, so per meter of the transect. So it's so total number of visits. And what we find is that, as I guess we might expect, as we get more closed, so this is that succession index going from 0 to 1, as we get more closed, the number of visits goes down. That's what we'd expect. But it's not related simply to floral diversity, to floral density, but it is related in a positive way to diversity of flowers. Okay, which is those two patterns seen left and right. And again, I was surprised. I broke it down and looked individually at the different major groups of insects, and they all follow almost exactly the same pattern. So the estimates, parameter estimates are slightly different, but basically with the same two variables coming out, the significant flow for all of those groups of insects across the transect. Diversity gets difficult. It gets difficult because I've got different lengths of transect. So I'm dealing with that by only using sort of rarefied diversity curves. And it's also difficult because I didn't have species level data for most of the groups. But what I decided to do for bees, butterflies, and moths and hoverflies, I was pretty confident that for most of the individuals I'd seen, I could at least ascribe to a particular tribe of insects. So I've got basically across those 3 major groups, I've got 20 different tribes of insects, and I'm using tribe diversity rather than species diversity as a diversity measure. And when you look at that diversity, again, it's sort of rarefied. We look at tribe richness, so number of tribes. What we get is this significant effect of succession again, but also a significant curvature in that effect. So there's some kind of hump-shaped pattern where you get maximal tribal diversity in the middle areas, and it just sort of drops off as you get more woody, and weirdly negatively related to floral richness in this case, rather than it was positively related in when we looked at number of visits. So that's the pattern I got with 2 missing data points, because the number of insect visits I got in 2 sections was so sparse that I couldn't do the rarefaction properly. And when you throw them in, so what I'm looking at here is just observed richness, so not rarefied, it's just what I recorded during the season, against just how much woodland there is in the section. What you see is it sort of maintains really well and then drops off a cliff when you get up to 90% woodland. So it looks like that sort of supports that hump shape curve that you do quite well until you get total woodedness, and then it all drops off. Also looked at different types of diversity, and I'm probably run out of time already, so I'll probably do this really quickly. That's what you've already seen. And as Ezra said, species richness is really sensitive to rare species because they only have to have one individual and it's another species. Chiltern diversity and Simpson's diversity are sort of sequentially less sensitivity to those rare species. And what you see is as soon as you start going away from rare species, succession drops out, and initially the floral richness effect is still there. When we move through to Simpson's diversity, both of those are dropped out, and we've only got floral density as being important, but again, negative. which is sort of a bit weird. We can talk about that. So I think really what's going on here, I think the reason we're getting that hump shape is that there are lots of species of, say, hoverfly, for example, the group I know best. There's lots of hoverfly species that do visit flowers that are associated with trees. Some have larvae that grow in sap runs. Some have larvae that grow in rot holes. Some have larvae that grow in roots of plants such as hogweed. So there's lots of species that I think when you have bits of woodland, those species emerge and they join in with all those open habitat species, and so you get this sort of peak of diversity in the intermediate areas, and that seems to be what is going on. So yeah, I think I probably said all that, but how much have I got? 20 seconds to look through it? Right, so I can stop. I'll go away. Anyway, so just take home messages. All the things you probably didn't want to hear. Most of these species, that sort of weedy species that appear everywhere, are the species that are visited most by pollinators, generally. Some differences and sort of relatively predictable differences about which groups of insects visit different types of flowers. What was interesting I found was this number of visits is really predictable, just for more visits in open habitats. But when you start looking at diversity, you start seeing these more interesting sort of humpback patterns that seem to be reflecting basically habitat heterogeneity, I guess, different habitats providing different species to the community. Yeah, that's me done, I think. The question,
One question. Have you got a question, Brandy? Can I ask one then? So those species that were really commonly visited that are perhaps less desirable in the pavement habitats, are they commonly visited because they're common?
No, not entirely. So not so much in the pavement habitats, but say something like hogweed isn't actually that common.
Well, that's what I think.
But when you find it, it's absolutely plastered in insects. So it's not just common. And then similar on the opposite scale, potentilla is really common in the edge of the bracken beds and everywhere, and is really not visited.
But is it also to do with timing? Because both of those, bluebell and potentilla, are early.
No, because it's like when bluebell's flowering, you get loads of visits on dandelion, on Taraxacum, all over the place. So bluebell is just not like. Yeah. Sorry.
Could it be that the rare species now have not been doing so well because they've degraded these limestone pavements, that the insects have just sort of over the years got used to going to the more common species. Now
I don't know. And you do see on most of those flowers are yellow Asteraceae, aren't they, with their hawkweeds and the dandelions and all those sort of things, and they are visited. They are all visited quite a lot, and then you get things like all the nice things you want to see on like rock rose and your
could be that there's because you didn't differentiate other species, there might be some species of insects and pollinators that do really depend on those rare species, but
yes.
Well, it could be that some of the specialists are lost.
Yeah, it could be. Yeah, it's already
It's already an impoverished
it could be that. Yeah.
insect